Jai Hind everyone, my name is Aman Gupta and I am working as an assistant professor in Ajay Kumar Garg Engineering College. Today my subject is software quality engineering whose subject code is BMC03Y5. So let's start with. Today we are going to discuss about software quality management models. Okay, so first of all we need to understand that what is the modeling process and what is a model. So modeling process in software quality management refers to a structured approach that is used to define, measure, analyze and improve software quality by using well-defined quality models. So we required software quality models to have an approach that has been used to define and measure and analyze the software code. So this is done by having well-defined quality models. For this, we required the quality models, and it absolutely helps in convert abstract quality requirements into quantifiable metrics that we can measure and enabling effective quality control and assurance. So these are some objectives of modeling process. First of all, to identify the key quality attributes. And what are these key quality attributes? That is reliability, usability, efficiency. These are all the quality attributes that have been required when we develop a software and when we have to assess the quality of that software or software product. So to provide measurable metrics for quality evaluation, if we need some calculated amount or using some formula, then we need to have some quality evaluation, and that can be done by using some formulation to support decision making and process improvement. By having a modeling process, it is easy to working upon the decision making and to improve the process. And this is the main objective of modeling process, is to ease the process, to predict the software performance and the defect behavior. It is also important part that to predict the software performance and the defect behavior. So these are all the objectives of the modeling process. Now there are certain steps in when we are going to implement modeling process, then there are certain steps that we need to follow. First of all, identification of the quality goals. So there are certain steps that first of all we have to define the quality requirements based on the user needs. That is also a first step when we talk about software development life cycle, that is requirement gathering, or that is the requirement that is actually needed by the customer or the user, and we have to analyze that what are the quality requirements. So gather these requirements or to identify these requirements is the first step when we are talking about our modeling process. For example, high reliability for banking software. So when we are talking about a banking software, the reliability because in this, when we are talking about banking software, there are finances included in this, money transactions. So this is a very crucial matter for the banking person or for the customer. So for this, if we are talking about this type of software, a reliability is a major requirement for the perspective of both sides, for the client side and for the developer side. So first is the identification of quality goals is very important part. Next is the selection of quality model. So we have different type of quality models available, and we have to decide according to our requirement that what type of model we need to incorporate in our software. So this is the important part, that we have to select that quality model, and we have some commonly used models, that is McCall's quality model, Boehm's quality model, ISO model. So these models categorize quality into factors like correctness, efficiency, maintainability, and many other attributes also. So according to these quality attributes, we need to identify that which model suits our requirement best. Now, next step is the identification of the quality attributes. So, for this, we need to break down quality into measurable characteristics. For example, reliability, mean time between failures, that how often our software fails when we are working in a duration of time. Next one is the maintainability, that is mean time to repair, what time it requires when there is an error occurs, then in how much time it will be repaired. That is the maintainability part. Next one is the metric definition. So we have to define quantitative measures for each attribute, that how can we measure according to some formulation. For example, we can find out the defect density, and we can find by this how many number of defects in a software over the size of the software. So size of the software, we can have size by having the lines of code LOC, that suppose we have 100 lines of codes, 100 LOC, and we have 4 errors in this code. So we have defect density equals to 4 by 100. So we can find out defect density by this formula. This is for only for an example. Next one is the data collection, and this is collect data through testing. We can collect data through testing, reviews and inspections, and operational use. So data can be collected through various ways, in which these are some ways through which we can collect our data. Next one is the model construction. So establish relationships between quality attributes, metrics, by which we can have relationships. We can construct the model by having the relationship between different type of attributes in a particular product or a software. For example, higher defect density means lower reliability. If we have a higher defect density, then we have a lower reliability. Next step is the analysis and evaluation. So analyze the data using statistical techniques, graphs, and trend analysis. We have multiple methods through which we can analyze and evaluate our data, and we have techniques like statistical techniques, graphs and trend analysis, and multiple type of other methods are also available. Helps in identifying quality issues and improvement areas. We can analysis always helps in having the identifying the quality issues and what improvements we can take in that area, or how to improve our code. So this has been done using the analysis and the evaluation. Next one is the feedback and continuous improvement. So feedback is always used to improve our existing software or existing work. So this results to improve development processes. Development process can be enhanced or improved using that feedback, and enhance the product quality. This is also important part, that to enhance the product quality, we have used our previous feedback to our product or to our software, and we can easily list out the points that where our product lacks in previous version, then we can easily improve that product in terms of quality or in terms of any development process. So it supports continuous quality improvement, CQI. Now, what is the importance of modeling process? So it provides objectives and measurable quality assessment, and helps in early defect detection and prevention, supports risk management and decision making, ensures continuous improvement in software processes, and enhances customer satisfaction and product reliability. So these are some importance of modeling process through which we have a clear picture of what we are going to do, and there are certain features that how can we measure product quality assessment, how can we done our quality assessment, what need to be done for early defect detection and how to prevent it, risk management, decision making and continuous improvement in the software processes, and the customer satisfaction and product reliability. So these all are the importance of the modeling process. For example, if we are taking a real-time example, that for a banking software system, quality is very important, that high reliability and security. This is the major concern if we are talking about of a banking software. So model used is ISO IEC 9128 and matrix is defect density and failure rate that we need to work upon. And the process is data collected from testing and user feedback. This is the process. Analysis shows high defect rate in transaction module, and improvement actions is code review and additional testing. So these are the process of using a model inside a banking software system. So result is, what is the result? Reduced defects and improved system reliability. When we are using a modeling process like ISO, then it results in reduce the defects and improve the system reliability. So overall, we can say that the modeling process is a crucial component of software quality management, and it also ensures systematic evaluation and improvement of software quality. So by using structured models and metrics, that is, an organization can achieve high quality, reliable and efficient software systems. Now next is our software reliability models. We have some software reliability models that are mathematical models that are used to predict and measure the reliability of software systems based on the failure data. So these models help in estimating failure rates by predicting the defect trends and by improving testing and maintenance strategies. So these are some points upon which the software reliability models work upon. So in this, first of all, we have the relay model, and relay model is used to represent the defect discovery rate over time, that is forming a bell-shaped curve, that is the bell-shaped curve. And its mathematical formulation is the relay function is given by ft equals to this. And in this, t equals to time, sigma equals to parameter related to peak defect occurrence. So this is the formula through which we can find out the ft. Okay, function upon the time t. Defects, characteristics of relay model is the defects increase initially, reach a peak, then decrease. That is, defects increase initially and reach a peak point. This is the peak point. Now suppose if we have this is as a peak point, and then it starts gradually decreasing over the time. So peak represents maximum defect detection rate and then useful for project effort and the defect prediction. Application of this model is to estimating the testing effort and predicting the defect density over the time. Next model is the exponential distribution model, and the concept behind this is this assumes a constant failure rate, meaning failures occur randomly over the time. That the failure rate is been a constant on a constant. In relay model, first of all, it gradually increases, then reaches a peak point and then start decreasing. In this model, there is a constant failure rate. If we have this type of graph, then this is a constant graph failure rate, meaning failures occur randomly over the time. So we can have the reliability rate by using this formula, where this is equals to failure rate and t equals to time. Now, there are some characteristics of this model is memory-less property. Suitable for the stable system, simple and widely used. So, this model is used very frequently according to the user need, and the application of this model is that reliability estimation of small or stable systems and used in early stage modeling. Now we have some software reliability growth models, and SRGMs describe how software reliability improves over time as defects are detected and fixed during the testing. So these models are, in these models, software reliability improves over the time because defects are detected and fixed during the, at the time of testing only. So in this, the software reliability improves over the time. So there are some popular models under this category, that is Zelensky, Moranda model, Goel Okamoto model, and HPP model. We have usually said to. And there is a general form. There is a formula where this is equals to expected number of detected faults. This is equals to total number of faults, and this is equals to fault detection rate. Through this, we can calculate the reliability growth according to this formula. Now, there are some characteristics. Reliability increases as fault decreases. As we know that if the fault occurred in the software decreases, then obviously the reliability increases over the time. And it is based upon the non-homogeneous Poisson process, that is NHPP. There are some applications that predicting remaining defects and deciding software release time. We have this comparison of models, that first is relay. In this model, failure rate variable, bell-shaped and defect curve we have got, and uses effort and defect prediction. In exponential model, we have constant failure rate and random failures and simple reliability estimation. In SRGM models, the failure rate is decreasing over the time, reliability growth is increasing, and the release planning can be done because all the error remove type of activities have been done in the process of software testing. Now, the importance of reliability models, it helps in quality assessment and prediction and supports test planning and the scheduling. So, it improves software reliability and performance and also assists in decision making for release and readiness, release readiness. If we taking a real life scenario example, if we are talking about a web application project in early testing, high defect discovery, that can be done using the relay rising phase. So, in early testing, high defect discovery. In stable phase, constant failure rate, that is exponential, that is using the exponential assumptions, and continuous fixes is having through the SRGM, that is reliability improves. So, result of this is reduced defects before the release and improved user satisfaction. So, the conclusion of using the software reliability models such as relay, exponential that we have already discussed, and SRGM provide valuable insights into failure behavior and reliability growth, which enables better quality management, testing strategies, and decision making in the software development.